Welcome, and thank you for joining us for today's Ask the Pet Food Pro. These chats are brought to you by Pet Food Forum and the editors of Pet Food Industry, the magazine and digital content provider offering pet food expertise to the market for decades now. You can find our content at petfoodindustry.com. Ask the Pet Food Pro offers a great opportunity to connect with industry experts and ask the questions that are top of mind while learning information to help you and your company provide high-quality pet food and treats. Today's chat is about the importance of precision in processing pet food, especially with extrusion. It's supported by Buehler. Thanks very much to them. And our expert today is Dr. Michael Enzi Cheng, who is the Global Business Development Manager, Pet Food and Aquafeed for Buehler. Welcome, Michael.
Thank you, Debbie, for the introduction, and also thank you, Debbie, for thank you, Pet Food Forum, for this giving us this opportunity to share our view regarding the whole processing line on pet food. And I'll be more than glad to discuss with everybody, and not thinking about either questions or answers. We just want to have a good discussion on how do we improve the precision of your pet food products down the packaging lines.
Okay. So we're going to dive into that discussion real quickly here, but first I have a few housekeeping notes. First, you've all been muted to ensure that everyone can hear and focus on the discussion. So please submit your questions or comments in the chat box. Some of you did submit questions beforehand while you were registering, and we appreciate those. We'll try to get to as many of those as we can, along with the ones that you're submitting now. And finally, this chat is being recorded. The video will be available in about a week on petfoodforumevents.com. You can click on the Ask the Pro tab at the top to access that. Let's get to the questions and discussion. So Michael, you already mentioned precision, and especially precision extrusion. Why is that important? What do you mean by that?
Well, what I see, since I travel globally in the last 15 years to meet with pet food, either pet food manufacturers or aquatic feed manufacturers, and most importantly to us, like if you have a dog and cat in your house, and every time you got some kibbles, and then the first thing you open the bag. What I mean by precision is precision in the quality of the final product. Quality means it could be some characteristics. For example, for a regular round and brown kibble, you're talking about the size, the shape, the color, and also most important, also the nutritional profile that you provide with this piece of kibble. So when we talk about precision, most likely I'm looking at the precision of the final, the quality of the final product. Of course, extrusion system being the core system or the core equipment in the whole production line. This is the most important part we want to discuss. But keep that in mind. When you talk about the quality of the final product, extrusion is one of the key factor, but it is not the only key factor, not the only factor that will decide the product, the quality of the final product. That's why we use extrusion as example. But for the sake of reach a precision on pet food product, the quality, you must look at the whole production line. So that's what I mean. We want to focus on extrusion, but the whole production line, all the processing equipment, starting from intake, grinding equipment, sorting equipment, grinding equipment, mixing equipment, preconditioning, extrusion, drying, and coating, and all the way to the packaging line. You need to pay attention on each single piece of equipment, so you can improve the performance of any piece of equipment you need, and then you can reach a certain precision on product quality. So that's what I mean, precision, yes.
Okay, and I mean, of course, quality is of the utmost importance, and that's what, that's sort of the entry point for pet food manufacturers for consumers, for pet owners. But I mean, is this a current trend that you're seeing or hearing more about, in terms of that focus on precision? Is it playing into any current trends? I guess is maybe a different way to ask it.
It's exactly right, Debbie, because when I not only, let's put it this way, because North America, we're talking about North America, US and Canada, pretty much we are here, we are the leader of the pet food industry in the whole world. And people around the globe, pet food manufacturers and even pet owners, they are looking at us and they're trying to look at the trends that what we are doing. And what we're doing that in the last 10, 15 years, we see a lot of things happening, especially on the part of the formulation part. We put more natural ingredients, we put more meat or more animal protein or fresh animal protein into the process. And,
right.
and also on the other hand, because the awareness of these issues that happening around the world with people looking at maybe some certain alternative proteins that include into the pet food, and those are the we talk about nutrition, formulation, and most importantly pet food safety. I'm pretty sure those are very relevant topics that we want to talk down the road. But today I would like to focus on processing, especially on the precision of how do you handle, how do you keep an eye on the performance of all your processing equipment. And that's the reason being that one of the main driving force of that is if you're a pet food manufacturer, you are looking at the price of your raw material, your raw ingredients. Right. The price of those raw ingredients, not only the price is increasing on I'm not saying daily basis, it could be on a weekly basis, and also the availability of those raw ingredients, raw material is getting, we're looking at issues, not right. only pet yes. food and also human food. So those are one of the driving force that we need to pay attention to: how much we consume, how much we can produce, what is the waste, and also what is the energy cost. I mean, we talk about the energy cost. Did you see the price for natural gas? If you see the change in the last couple of years, especially this coming winter, you're gonna ask yourself, how could we do something to improve our process to save the natural gas? I mean, save energy and those raw material costs, so that will make make your process more sustainable in the coming years. Because this situation is not going to be changed, not going to be improved in a couple of years because of the current issues of supply chain issues. So right. that's why this is the trend of you have to make sure that you have this, keep that in mind to save energy and raw material. That's why I want to make sure that we can make use of all those raw materials we have on hand at the most efficient way.
Right. Yeah. There's a lot going on in the world that's affecting every industry, including pet food. So you mentioned the entire production line. So why don't we start farther up the line, before the formulation is ready to go into the extruder. There's some steps that have to take place, like granulation and grinding. What's the significance of those, and how do they play into the whole precision concept?
Thank you, Deb. That's a great question, because when you see starting from in your whole facility, there are several processing steps that actually you use a lot of energy, and you can control the use of energy by the performance of your equipment, and also by a certain automation. Because when we talk about the granulation equipment, grinding equipment, or particle size reduction equipment, most likely what I see in the extrusion line, that down the road, it's depending on your product. Most likely when you see a regular standard pet food, I would say a standard round and brown kibble, and you don't have to grind your raw material to a really fine granulation, because this happens a lot. People tend to grind their raw material a little bit finer than they need. They just, because the issue is that because their control system, their equipment they don't want any larger particles that can get into the system that can down the road will have some negative impact on the product. Because what we're trying to focus here is we try to provide a consistent particle size really close to what you need. For example, on your hammer mill, let's use a corn as a example. When you have a raw material corn coming inside, you want to use maybe a 2 millimeter size of screen, and then you try to focus on your product at a certain the granulation at a certain point. So this is very important. If most of your particles falls into a close, let's say, particle size, it is easier for the next step, especially for mixing. It is much easier for the mixing to reach a certain homogeneity, homogeneous flow, and then you have a particle size distribution with a really flat curve. We want to see a really sharp curve with intended particle size. So not only for mixing and down the road for extrusion, and then for preconditioning, when you have a particle size, relatively uniform particle size, it's easier to achieve a certain uniformity, especially on the pre-cook levels. So and that's why we want to make sure that you need a certain grinding equipment with a certain automation to make sure that you will achieve this granulation or particle size distribution as close as possible to your setting point. And this is, I mean, I understand it's easier to say, but there's a way. Because Buehler Group, we just announced our new Granulex system that we can. It's a module system for hammer mills that we can achieve a certain capacity and reduce the energy cost up to 30%. Also, you're looking at a much smaller footprint in your facility using this kind of a hammer mill. And because of the automation that comes with this application, we really look at a really fine, a really close particle size distribution.
Okay, so just to sort of sum up, so uniformity and consistency are really important in terms, and then your product should determine the actual particle size. But you don't want to get it too fine because then you waste energy. Did I hear that correctly?
Exactly. When you get too fine, not only you're wasting energy, those really fine particles down the road will give you issues, and not only preconditioning extrusion, and also down to the dryers. I would like to mention about dryers, and then if you look at your dryers, you see a lot of fines accumulating at the side, and those fines are not coming from nowhere. Those are fines that could be from the overgrinding of your raw material.
Okay. All right. So we've had a couple questions come in while you were talking about particle size. They're sort of related. So one is asking, are you comfortable suggesting an average particle size target in microns? And then the other one is there a max particle size for raw materials?
Yeah, that's exactly right. Those are very relevant questions. And we're looking, if you're talking about 5 millimeter cable, though for extrusion, let's say for extrusion, we talk about your largest particle in your formulation should not be more than 30% of that the die hole. So in this case, if a 5 millimeter, you're looking at 30% will be 1.5 millimeter. That will be 1.5 millimeter. So that's the largest particle you should have in your grind. So that's exactly right. It's really depending on your final product, and to us, and we follow this rule of thumb for extrusion. 30% of it's the particle, largest particle in your material flow should not be larger than 30% of your die opening. So that's the rule of thumb. That's
Okay. Okay, sounds like a good rule of thumb for people to follow or to consider. And so that answers it. So there is no such thing as an average then, because it's really going to depend on your equipment and your product.
That's exactly right.
Okay, all right. And then so then I may not be moving exactly in the right order, but after grinding and all that, one of the next key steps is preconditioning. How much does that affect the final product quality, and how can you optimize use of the preconditioner?
Well, the preconditioning, I mean, it's we can talk about preconditioning all day long. This is actually one of the equipment that will make or break your whole production, because the preconditioning, the major job for preconditioner or preconditioning is to mix to transfer the thermal energy. I would say thermal energy using water as a media to transfer the thermal energy into the particles. So if you see that, and then you have a certain pre-cook the material out of the whole preconditioning system. And again, you don't want to overcook your material inside the precondition. Not only you waste time, energy, and also you will have issues down into the extruder. So what we suggest that from all those issues we have been looking at, because preconditioner is uniform for extruders, not only for pet food and also for aqua feed. We see some extreme cases. For pet food, we haven't seen some extreme cases, but for aqua feed, we see some extreme cases. They need much longer preconditioning than pet food. So, for example, we have projects producing shrimp feed. And at certain time, they need up to 4 minutes, 240 seconds of preconditioning inside the whole preconditioner system to make sure they achieve a certain cooking level, so they can transfer that into the extruder barrel. So in this case, if you see your product coming out when you start to packaging your product, when you see the product, you see the shapes and colors. If you see some issues with the shapes and colors, most likely you have issues with your precondition. That's why at Buehler, we definitely recommend using a multi-stage, or in pet food, most likely you'll see we recommend a 2-stage preconditioning system. What I mean is that you want to separate the preconditioning and retentioning into 2 different vessels. So for example, the preconditioner, pretty much, we all insert steam and water into the preconditioner, and that's what try to mixing, and then we have a really intense mixing inside the preconditioner. We want to make sure all the raw materials, they'll have a full contact with the steam and the water, and then this intense mixing stage is gonna be a relatively shorter stage. And then the next step is when you transfer these mixed material, hot mixed material, into a separate chamber, which we call a retentioner, and that's when real retention is happening. That's people didn't pay too much attention on that. They think we just need most likely you see all the preconditioner system here in North America. You see, and maybe we call it 1 stage. Most likely you see a double shaft preconditioner. But what we see that the advantage of a 2-stage means you have some real retention time. Just like when you bake a loaf of bread in your house, after mixing everything, you want the dough to relax for an hour, maybe a couple hours. Some extreme cases, I know my wife is a baker. She's doing some overnight fermentation. That's a different story. Fermentation, relaxing. So you don't put the dough right after mixing into the oven. It's not going to happen. You're not going to end up with something very, very different, not a piece of bread. So similarly, in this situation, after mixing of those raw material with steam, water, the thermal energy, it takes time for the thermal energy to transfer to the center of the particle. This is even very important for pet food. So just like I mentioned, for example, if your average particle size, let's say, is about 1.5 millimeters, it takes some certain times, maybe 120 seconds to have all those energies, thermal energy transfer into the center part, because the larger particle, I would say 1.5 millimeter is considered a relatively larger particle. For a larger particle, it's kind of easier to mix the material, mix the raw material with steam and water, but it takes time to penetrate for the heat or energy to penetrate into the center of the material. In other cases, like I mentioned, in the other cases, like the aqua feed cases, when you have some really fine grinds, for example, you see you're looking at the 600 micron or even 800 micron in that level, it is very difficult for the material to have a really nice homogeneous mix, but the heat transfer is faster in that case. So there, I mean, now we focus on pet food. In this case, you need we recommend this two-stage preconditioning and retentioner to make sure you have a real retention time. So, and also what I see the advantage of a single shaft preconditioner and a single shaft retentioner, the advantage is that you have a real first come, first out action. So, I mean, I don't have to mention why we need first come, first out. I mean, it's just you want all the materials inside the preconditioner system. They have similar, or not exactly the same, but they have to have a similar experience when we talk about heat treatment or mixing. So that's so that's how important the preconditioner system is.
And then the retentioner, that besides retaining some of the heat and thermal energy, it also transfers the material into the extruder. Yes,
after the retentioner, it's time to transfer the material into the extruder. And it's very interesting. You see how you transfer those pre-cooked or pre-mixed material from the preconditioner system into the extruder barrel, because most likely in North America, we see people rely on gravity. So, I mean, you see extruder with a downspot. That part from preconditioner to the extruder barrel, you see a downspot. We call it downspat. In that spot, pretty much its material should flow into the extruder barrel by gravity. I mean, I don't mean it is not good, but if you compare this action, gravity, with what we recommend, it is a forced screw feeder from the preconditioner to the extruder barrel. That means you have a consistent flow from the preconditioner system or retentioner to the extruder barrel, no matter how. Because if you look at those preconditioner materials, especially those raw materials with very high moisture, very high, sometimes high, sometimes high lipid or fat content, and those material is not going to flow as you wish. They will stick to the walls. You will see issues with capacity flow into the extruder. It's not going to be as you wish, because, for example, you're looking at a, let's say, 10-ton per hour system. From the preconditioner to the extruder barrel, I don't believe you're going to have a consistent flow of 10 ton per hour with that gravity system. That's why. And also the other issue is what I've seen, that some of the manufacturer I see from the preconditioner traveling to the extruder, I see even extreme cases of even 6 feet or 7 feet of traveling for those materials. That's going to be, I really don't believe you're going to have a consistent flow of material with this kind of a distance traveling from preconditioner to extruder barrel. So that's why with Buehler, we have a forced screw feeder to give you this guarantee of capacity flow into the extruder barrel. So this consistent flow into extruder barrel is going to be crucial for your extruder performance, because the more consistent flow, your motor load going to be more consistent, and down the end, the pressure built up inside the extruder barrel, especially for single screw. This is very important. The more you fill the barrel, and the more consistent the barrel is filled, and then the product quality, the product coming out of the extruder, is more consistent. So that's exactly our recommendation, to think about how you transfer material from preconditioner to extruder barrel.
Okay, we're going to take a pause there in terms of moving along the line. We've had quite a few questions come in. Going back to the grinding stage, a question came in: does the particle size limit apply to all ingredients, even for ones with low inclusion rates, for example, below 1%?
Well, that's a great question, because what we're talking about is all those large, I call the large, I would say the macro ingredients. Those I would say the fillers or the carriers, like those starchy components. If you see some really fine equipment, that's a very relevant question. If you have something that under 1%, that kind of ingredients, you use a certain fine or micro dosing system that you dose that into the mixing part. That's actually is not most likely those ingredients. They are already in you purchase those, the particle size is already preset, so you don't need do anything about those kind of ingredients. So
that makes sense. Yes. Okay. So then moving on to the preconditioner again. Someone is asking if you can please discuss gelatinization in the preconditioning process. What is the desired target for gelatinization in this part, and what is the desired retention time in preconditioning to reach the desired gelatinization target? Okay. Multi-part question.
That's interesting, because that's a very another interesting topic we want to talk about, gelatinization. When we talk about cooking level, we talk majority in the pet food formulation. You see the starchy component, the protein component. For cooking, quote unquote, cooking for starch is gelatinization. You're looking at certain percentage of starch gelatinization. Also for protein is denaturation. So those are relevant inside the preconditioner, because the thing is we're looking at maybe 40% to 50%. That's already on the high end of gelatinization inside the preconditioner, because gelatinization you're depending on heat, thermal energy, and the water content. Most likely in a regular pet food production in the preconditioner, you are not looking at moisture content over 25%, 26%. So you're looking at something really lower in the lower end. So that's gelatinization is not going to happen 100% inside the preconditioner, because of the condition that you have in there. So on the other hand, the retention time, because when you talk about retention time as a whole, including preconditioning and retention, because most likely you'll see for regular round and round 90 seconds to 120 seconds is good enough, unless you have some certain raw material, like maybe a high protein diet. You might need to consider a little bit longer time than that. And also you need again, everybody needs a preconditioner system that you can actually have a control of the retention time. You can control the retention time by certain structures inside your retentioner or preconditioner, the paddle arrangement, or the speed of the paddle spinning. So that's something you need to keep that in mind.
Okay, and then if you have a high starch product, so around 51%, how can you avoid overexpansion? Are there ranges in terms of grinding, preconditioning, and extruding that help handle that high starch so your kibble doesn't overexpand?
Oh, wow. Okay. It's a very interesting question, because we normally see formulation with high protein, and then when you see a high starchy formulation over 50%, now you need to go back to your the preconditioner. So how do we set that preconditioner? That because all the expansion happening, if you look at the whole extrusion system, you want to look at the pressure build up before the die. So anything that get into the die system, get to the die, and then you see the difference of the pressure, because that's the expansion most likely is going to be decided by the pressure difference before the die and after the die. So if you look into that, and then you have to a certain barrel, you need to look at your not only also the die hole size, the die hole design. How do you relax that? So those are, we need to put those into consideration to see. And also we want to see what kind of a target of your expansion. Most likely we're looking at 50% of expansion for a regular pet food product. And then when you say over expansion, what do you mean by that? And actually we see some manufacturers, certain pet food manufacturers and certain product, they really want a really light product in the 220 gram per liter range. I'm sorry for I'm using a metric system because it's 220, and then you see they actually want a higher expansion for a certain product. So again, you want to look at the pressure difference and also the die hole design inside the processing route.
Okay. And when it comes to mixing efficiency, so the question is if Buehler equipment it has a CV, I'm assuming that's like a control.
Yes, it's called coefficient of variation. So that's,
yeah, sorry about that. I knew it was something I knew. It was just one of those things that wouldn't come to me. But so is there a CV to shoot for? And if you're able to measure a CV of 3% or less, is first in, first out as important?
Yeah, that's a great question. Yes, we have for Buehler mixing equipment, there has to be a CV1 target. Most likely you're looking at it has to be 95% over a certain homogeneity. So there is a certain way we measure that, and I would love to have one of our experts in mixing. We can give you more if you. That's a great question. If you really need some assistance on that, get back to me after this event, and then I will hook you up with with one of our experts in mixing, and then you will get some really interesting or some answers that you will like. So.
Okay, and we will, by the way, folks, we will be providing Michael and his company the text from the chat box, so they can also follow up with you for specific questions for your specific processes and products. So you mentioned the retentioner is used to allow heat transfer to the center of the particle. Are you assuming the environment temperature inside the retentioner is hotter than the center of the particle?
The environment, yes, definitely. When the particle here what happens after the intense mixing, very intense mixing of steam and water with the raw material and in the precondition, then they will transfer into the we call the retention. So at this time, the material temperature, the thermal energy is at this time is transferring into the particle center of the particle. And then, of course, the whole environment inside the retention of the temperature should be higher than the center at this moment. But what we see is that because this whole system we are looking at from Buehler is a closed system, what we see that, for example, I see some issues with certain pre-container systems. You see steam coming out. Not only for pet food, I see some. Especially in aquaculture, you see somebody has to put a certain chimney-like structure on top of the preconditioner to let steam out. For our system, for Buehler's two-stage system, it's a closed system. No steam will be wasted. That's one thing you want to manage your energy, manage your energy consumption. This is something that you don't want to lose steam. When you lose steam, not only you are losing steam energy, you are losing some of the fine particles we talk about, and then some of the fine particles could be those really fine ingredients, really micro ingredients you include in there. So that's why we want this system to be a closed system. So no steam should be leaking out this system. Period.
Okay. Okay. So moving along to extrusion, let's get back to some basics here. We've had some questions come in before today and then also just now. What is the difference between a single screw and a double screw extruder? And are there, certain uses for either within the pet food range?
Again, it's kind of it's a very broad question, but I will definitely say this. I've done say this. For twin screw shooter, for pet food industry, even at this moment, use majority of shooters are single screw shooters, because we can using single shooter. Of course, you are looking at the less investment, less energy cost, less mechanical and less parts, less maintaining costs. So all those running costs, definitely single screw is less than twin screw. But at a certain time, if you want to produce some, let's say, treats, those high moisture, high oil contents or fat content treats, it will be extremely difficult for single screw to pass through, because the slip is going on inside the extruder barrel, between the screws and the liners, because of the nature of the product. Say if you have really high oil content diet, this is slipping is gonna be there, and the cooking is very difficult inside single screw barrel. So in that case, you want to consider a twin screw. And also, I can expand a little bit about the food industry. For example, at this moment, the alternative protein or plant-based protein is a huge industry. It's growing like crazy here, not only in the US, it's going globally. And to achieve a certain structure that a twin screw, in this case, with that kind of a high protein, you're looking at inside the extruder barrel with those raw material, you're looking at more than 50% of protein inside the extruder barrel. So those are very difficult for single screw to handle. And I didn't say it could not handle. It may be able to, but a twin screw will give you a really peace of mind to handle this situation and give you a beautiful structure coming out of the extruder die. So again, single screw again is still the major working horse for the pet food industry. So for those regular pet food, I don't see any issues using single screw. But for some certain formulations, you want to look at the difference between single and twin. A twin could be a better fit to give you a better performance.
Okay, so more of the, this is a generalization, but more of the specialty type.
Exactly, specialty.
Pet foods and treats, which anymore is half the market. But yeah, I think you're right. So so you touched on high protein, for example. And, you mentioned earlier the trend to use new ingredients, for example, natural ones. So what other challenges might you get with certain types of ingredients in the extrusion process? Are there others that either require a twin screw, for example, or different processing parameters, or are there any others that come to mind? You mentioned high fresh meat content. That's
okay.
One.
Yeah, high fresh meat is definitely another challenge. That high fresh meat is a product, especially the higher the fresh meat content, the higher the moisture content is inside the preconditioner, from the preconditioner into the barrel. So we have extreme cases when you have a really high moisture content flow into, because if you talk about fresh meat, let's say fresh chicken, about 70% of water. And when you include, let's say 50% bakers, even 50% of bakers ratio into your dry material, and then you are inside the extruder barrel, you are looking at up to 32, 34, even 35% of moisture. In this case, you need a certain high mechanical energy to actually cook that inside the extruder barrel. So, but with that kind of a high moisture, and also high fresh meat also means high fat content. So in this case, it will be difficult for single screw to handle. So at a certain time, at a certain level of fresh meat, you would consider a twin screw to give you a better cook inside the extruder barrel, and also more importantly, a consistent product appearance. I'm talking about the size, the shape, and the color after the extrusion process.
Okay. Are there maximum levels for fresh meat or for protein or fat that either kind, or is that again depending on a lot of variables.
I've seen, for Baker's ratio is a very it's a magic term, because in Baker's ratio you can achieve over 100%. And then you're looking at, I see even in our lab, because I haven't seen anything in the market that over 100% of a fresh meat claim that we have over 100% of fresh meat in their formulation. But because you cannot claim that on your label, by doing that you have to using a ratio of a regular percentage ratio based on the ingredients. So, but in the lab, of course, we do certain tests over 115%, or sometimes we achieve 120% Baker's ratio on fresh meat content. It really depends on the market. Maybe the market is going to that direction with the highest fresh meat you can be doing, but if the market is going down to that end, the highest fresh meat, yes, there's a limitation. It has to be done on a twin screw when you reach a certain fresh meat content.
Okay, so there's always limits, but it really has a lot of variables. And let's be clear, just in case it's not clear to everyone, the percentages that Michael's talking about are in terms of the percentage of the formula, correct? Or by weight, by dry matter weight? Is that what you're calculating?
It's a ratio between the fresh meat to the dry formulation. Most likely, when people are doing formulation, it's easier to use 100% at the dry as a base, and then you add into the fresh meat at a certain ratio. So that's what I call a Baker's ratio. And because it's my wife doing this a lot because she's a baker, so that's easier for her to do the formulation. So
okay. So I think that answers a lot of questions that we have, because we had quite several come in about maximum levels for different things, and it sounds like you have to see what you have to have a balanced formulation that meets the animal's needs, obviously, complete balance, and then also balance the dry versus the meat and the fat and everything else.
That's exactly right.
Right. In terms of newer ingredients, especially newer proteins, have you worked much with insect protein, and does that call for, does that work okay on single versus a twin screw? Or are there other processing factors to consider?
That's another very relative, relevant question. Is that insect protein is coming, because as a builder, actually, maybe you know that builder is the one that already working with a major insect protein manufacturer in Europe.
Right.
We're looking at really high volume insect protein coming into the picture, but so far we haven't seen any issues in the production part using certain, because the insect protein the portion or the ratio of insect protein into the formulation is still relatively low, so we don't see any issues. But at this moment, we're looking at we are doing tests globally using insect protein actually into a certain aqua feed. Not in the pet food yet, but we want to test them in the aqua feed and see the impact on the aqua feed, and then we'll introduce into not only pet food. Maybe down the road we'll introduce those into human food too, because we have seen some snacks using a cricket meal making a human snack. So it's gonna be interesting.
Yeah, and there are a few dry extruded pet foods on the market with the insect protein. So I think you're right. It's gonna continue to develop. What about things like yeast protein? Does something like that call for any special processing parameters?
Debbie, can you repeat the question?
Yeast protein.
Oh, yeast protein. That because we. Well, if you look at the protein, people looking at a amino acid profile, because we all see that if you compare plant-based protein with animal source protein profile, of course the protein profile, I'm talking about amino amino acid profile from a animal resources is much complete than protein. Yeast it could be something in the middle. So that we see people doing this, but we're still working on a certain formulation that with several certain partners. So we cannot give that kind of conclusion at this moment, because those customers we're working on, we have some agreement signing, so not at this moment. Maybe the next one we're talking about in about a year, we might have some conclusion when we can work together to have some publication talking about those impacts.
Okay, and I'm assuming it's a similar scenario with other non-animal proteins. For example, you mentioned plant proteins earlier, other plant proteins, and then of course there's algae, there's microalgae, there's all kinds of things being looked at. You know, I'm assuming that those are all they're being used, but in terms of them being more of the total protein source, I imagine that's still involving some research and testing.
Yes, because at this initial moment, when we do this kind of it's a scientific approach that you're going to replace a certain part of other ingredients. At the very beginning, you are not it's not going to be dramatic portion. It's going to be a small portion, and then if you don't see any significant difference, you're gonna move into another portion, maybe a higher portion, a higher percentage. So all these tests are carrying on, and then at a certain stage, you're going to see some significant difference, and then that's when you start to do some analysis of why this is happening. So again, it's definitely people looking other resources for proteins. Then we have to keep something in mind. It's the reason now we're looking at animal, especially insects, as a protein source, because when you look at the amount of the insects, you're looking at billions of tons that is available. Right. And but processing them is a nightmare, because I can definitely tell you processing them it's nightmare, because it's especially drying part, and that can be very challenging. So I put this way. So
okay, good to know. And yeah, I think one thing that's important to mention for everyone tuning in is that, you know, if you have an extruder in your company, likely the manufacturer, no matter who that is probably very able to help you do some testing on different types of formulations, because I know in addition to Buehler, a lot of the you know, extruder equipment manufacturers do offer that, or if you work with a co-packer or co-manufacturer, they should be able to help with some testing if you want to try different kinds of proteins, different levels of meat, things like that. So you know, that is a resource for most people. And so then we just had a question come in about drying, and I was about to move to that, so very good timing. Okay. So what type of dryers are more, you know, are there types of dryers that are better for pet food processing, for example, like vertical versus horizontal? And then in terms of the energy source, you know, gas versus electric.
Well, it's Debbie, you got me there, because I don't want to get into the fight. But the thing is, what we have been looking at globally, and also North America, I still believe at this moment, the horizontal, or some people we call that a belt type of dryer, is still the one that give you a consistent volume, not only consistent volume, also a consistent moisture content, because and also because you know, maybe because Buehler Airglide, we've been in this business since the 1940s, 1950s, and then we have a complete line of equipment, especially dryers, and then also with the improvement of sensors and automation, I can proudly say, I can guarantee you that from a Buehler Airglide dryer, I would say horizontal dryers, we can definitely deliver a product that can give you a very, very narrow variance on moisture content. And this I don't have to give any lessons regarding why we want to keep this variance moisture content as thin as possible, because everything coming out of the dryer is money, and then to me, extruder is something gives you the feasibility, and the dryer is something that define your profit. I mean, you need to not only the product, and now at this moment, other part of the world, people using steam dryers. They use steam generators, use steam coils, and to dry the product. But that's because in that part of the world, because the natural gas is not available, and if natural gas is available, it's available at a very, very high price. And now, I mean, the natural gas price is not profitable, but natural gas direct heating is still the process that can give you a better efficiency than a steam dryer. So electric dryer, we need to look at. I love the idea of people being environmentally friendly, people being environmentally concerned about drying, but where electricity is from, we have to make sure that is that from how do you get electricity? That's other things we'll talk about.
Right.
So in that case, to me, I want to focus the final product, the precision, or the quality, or the consistency of your final product. So in that case, I'm still looking at, in North America, I would say in North America, we are kind of lucky. We still have the abundant resources of gas that we can use to dry the material to a certain level that we desire. But I don't, maybe, in this case, maybe down the future, if we I can tell you something interesting I have seen in Southeast Asia. People burn anything they can burn inside their burner to generate steam. And it's anything they can burn. Let's put in that concern. So at this moment, let's stay with the horizontal dryer with gas fired, and give you a better efficiency. So that's my opinion.
Okay. Someone had asked what an acceptable range for moisture content in the dryer is, and someone just responded that, plus or minus 1%.
That's indicates plus or minus 1% in the realistic world. I mean, if you can get that, it's already a good one. But if you ask the people that been running builder air glide dryer in the last couple of years, they will tell you you're looking at much thinner variation, plus minus 0.25, plus minus 5%, 0.5% is the target, and actually they achieve the target. So, I mean, I've been to facilities of a lot of facilities of that, and then in dryers, not only you see the product coming out, and also the other things is how you control the fines. Again, we touch a little bit about where the fine is from, and then how do you deal with the fines, and how do you control the depth of your product bed inside the dryer, and also the relative humidity of different part of the dryer. So those are something that should be resolved by a certain automation. And so far, I can probably tell you that Bueller Air Glide, we offer Bueller as a group globally. We offer the top automation that can give you a much better control over what you need. Even our customer, they gave recommendations. This is something that you want, not. There's a certain limit your equipment can achieve, your mechanical equipment, the mechanical part can achieve. But on the other hand, the automation will give you a much better solution or performance on your current equipment.
Okay. Anything else, related to the dryer that's important for people to keep in mind or any other steps as the product is going into the packaging?
Well, we talk about really a lot about the dryer performance. It is just that, you know, even builder, we have some people coming to us, builder air glide, we have people coming to us to improve the dryers, even though it's not a builder air glide dryer. So for the horizontal dryers, pretty much we can improve the performance by a certain percentage. It doesn't matter whose dryer is. But the other thing I want give somebody a heads up is it's a, you know, for people like me, we travel globally, and then every time, you know, especially when you travel, when you pass the security line, most likely you'll see a big case of demonstrate. I call it demonstration case. You see all the weird stuff people trying to carry. People try to carry. You see those. You're amazed. You'll be amazed what kind of things people want to carry on the airplane. But you think you have a really nice, or hygienic design line that you eliminate all the foreign matters before packaging. Think again, because we have seen it all, and then people even say, hey, if you pick up something before the packaging, you know, this is something that we can revert. But you will be amazed what we can pick up by our Sortex. We have a Sortex, we call it the Sortex optic sorter. We can pick up a lot of things that some of them, the most interesting I have seen is even some pieces, some cables with a certain smaller piece of plastic wedged or whatever, or forged into that cable multiple times, and also hairs. And if I'm a cat owner, so when I open a bag, if I see a cable that is kind of a shrinked like a piece of a little stone or something, I'm not happy. So think again before your packaging. Maybe if you, I want to challenge everybody, maybe send a couple bags, maybe 100 pounds or 150 pounds of your product that you want before packaging, send it to Minneapolis and then to our test facility. We will show you what we can pick from there by our Sortex machine. It's amazing. I mean, I'm not doing a commercial, but it is amazing to see, because it's amazing to see what you can pick up from by that machine, by the Sortex. It's kind of a it's eye-opening experience. So that's why that could be the last stop, last guard of food safety before you send to the packaging. I mean, it's definitely worth the investment to have something of that a optic sorter right before your packaging. So
yeah, definitely. So one last question, and then I think we're about to the top of the hour, and that's to do with the coating step. So, you know, is there proper sequencing of additives and time allotment? You know, also, do you have recommendations for atmospheric versus vacuum coating?
Well, I you know what, I don't have any preference. It's really depending on what stage you want the most likely coating. You know, for pet food, I don't see too much vacuum coating. Most likely, I see a lot of vacuum coating in aquatic feed, especially those you're talking about those salmon, those kind of feed. They need a lot of extra fat, because in some of the cases, you have to coat another 25, even 30% of fat after the dryer. So in that, with that kind of a percentage of fat or oil, you have to use a certain vacuum coating. I mean, it's not, to me, it's not even coating, because all those fat or liquid going to be absorbed into the cable. It's not coating on the surface. So when you talk about coating, most likely you see a little bit surface, and then in a regular coating equipment, you're talking about maybe 7 or up to 10%, and that's already the high end for regular you know, atmospheric pressure kind of a coating. But I don't see, maybe there's some certain specialty product that have a high fat oil content, you have to use a vacuum coating, but I don't see that much in pet food. Aqua feed, of course, a lot of them are using vacuum coating, especially for some certain diet I mentioned, those cold water marine species.
Okay. And what about the proper sequencing of adding the coatings or different additives to an atmospheric coater? Is there a proper sequence to that?
Oh yes, there has to be a certain sequence, because if you see the most of the kind of a drum coder and the drum coders, and then you see the sequence of different those nozzles spreading the fat and the liquid, and then fat is something that is interesting. If you want, some people even want to coat a certain powder stuff, powder kind of ingredients. Those can be done first, and then most likely you want to do the fat maybe at the last stage, because after fat is coated, nothing else can be coated. So that's the issue. So.
Okay. Okay. Well, we've covered a lot of ground today. Thank you to everyone for your questions. Thanks very much to Michael and for sharing his insights and expertise and answering all your questions. And thanks again to Buehler for their support. You can learn about other pet food industry topics. We'll be having more of these Ask the Pet Food Pro chats next year. So please watch for those. We also do a number of webinars, and those we have more already being planned for next year. And then if you're able to make it to Pet Food Forum, that's May 1st through 3rd in Kansas City, and registration is open now with early bird savings. So you can take advantage of that if you're able to. We would greatly appreciate your feedback on today's chat. If you can please take a photo of this QR code. We also will be sending an email with a survey link. And then finally, just another reminder that this is being recorded and it will be available as a video in about a week on petfoodforumevents.com under the Ask the Pro tab. Thank you again for joining us today. Thank you again, Michael. And I hope everyone enjoys the rest of your day or evening.
Thank you, Debbie.